let's look at processes and threads. How exactly does Android handle processes and threads? What is the underlying OS for Android? Let's remind ourselves one more time. It's a Linux kernel. So obviously, it must be taking support of the Linux underlying process support, process and thread support in the underlying Linux kernel to support activities. In Android, whenever any component of an application starts, then a process will get created if the process doesn't already exist. Okay? And no other component is running. Android creates a new Linux process with a single thread of execution, what we call as a main thread. Remember this main thread because we're going to keep coming back to the main thread over and over again. There are certain properties of the main thread that we need to remind ourselves when you write programs. By default, all components of an application run within the same process. Okay? All components, activities, services, everything runs in the same process by default. If there is a specific need that you want a certain component to run as a separate process, you can specify it explicitly by using this attribute in the manifest file. Okay? Now, when I tell you manifest file, you should be reminded of what I am referring to. Right? All of you know where the manifest file is. Right? All of you know what is contained in the manifest file. If you have forgotten, look at the code one more time in your labs. Android manifest.xml. That's where details are given. Okay? That's where you describe all the components. You specify all the activities, services, and so on. For a particular component, you want it to be started. When that component starts running, if you want to start a separate process for the component, you need to specify that explicitly in the manifest file. If you don't specify anything, Android will let all components run in the single process. Sometimes you may want to have a background service to be run in a separate process. You can specify that explicitly if you need to. For applications that you're designing, there may not be any need for these, but be aware that such a facility exists. If for a specific application that you're implementing, you need that facility, you can make use of it. But for standard applications that you write, you don't need to worry about the process attribute at all, because you would all be specifying such that all components will run in a single process. Now, when an application process starts up, now furthermore, in Android, you remember that processes are run in their own silos, SILO, silo, meaning in their own sandboxes. Each process runs in its own Java virtual machine or the Dalvik virtual machine. We talked about that in the first chapter about Android. Okay? Every process runs in its own Dalvik virtual machine. Okay? Within Android, as more and more applications run, as more and more components get started, you'll have more and more processes getting created. Now remember that there is a finite amount of memory within your device. Okay? As more and more processes get created, they will start consuming memory. Obviously, right? As you create processes, you have to create their address space. When you create their address space, they're going to occupy a certain amount of memory, and so on. And if this continues, eventually you might run out of memory, or eventually your system may slow down such that the Android framework may be forced to get rid of some of the processes in order to free up resources. Okay? So sometimes Android may need to remove old processes and reclaim the memory for more important processes. Now, how do you decide whom to get rid of? Okay? You need some kind of specified set of rules which say, I need to reclaim some memory. Who am I going to get rid of first? Now, you obviously want to get rid of those that will cause the minimum damage for you. Okay? So, you pick, the Android framework picks candidates to be killed based upon an importance hierarchy. Now, how is this importance hierarchy decided among all the processes that are currently active on the Android system? We'll talk about that in a minute, in the next slide. Once you identify the lowest priority process, the lowest importance process, you get rid of it first. And then you keep getting rid of low priority processes until you have reclaimed sufficient resources that you can stop. Okay? But the reclamation is included in Android. Why do you think Android does that? The reason is because when you turn on your devices, you keep them on for days or months together. Right? How many of you turn off your mobile phones regularly? Who switches off their mobile phones every day?
Maybe 2 or 3 days because I need to change the battery.
You need to change the battery.
Yes, because the battery running out so quick.
You don't recharge it?
Yes, but it's not enough for a day.
Oh, okay.
Oh, yeah.
Okay. But does anybody else switch off your mobile phones? When was the last time you switched off your mobile phone?
Last month.
Last night.
Yeah.
And then when will you switch it off next time?
Tonight.
Oh, tonight?
Yeah.
Oh, you are one of those regular ones. When I turn on my mobile phone, it is on for days together. In the old days, I was still old-fashioned, and I used to turn off my mobile phone at 9 o'clock at night, and then I would go to bed and then wake up early in the morning and then turn on the mobile phone after I woke up and so on. But then I saw people that they would keep their mobile phones on all the time. And very often, the moment they reach home, they plug it into their socket and would leave it there. And then I realized that probably I'm just too old-fashioned, so I stopped switching off my mobile phone. It will be on for like about a month before I even turn it off. Now, what happens if your device is running for a month? Obviously, you're making use of your device continuously, right? So you'll be creating processes, more and more processes every single time, and then you'll be passing through the next one. If there is no way for you to get rid of the processes, then your memory will soon get filled up. Okay? If it gets filled up, eventually the system will crash. So in order to avoid that situation, Android, ahead of time, before it crashes, it starts cleaning up its own mess. Okay? Now, for doing this, you need to be able to identify whom to get rid of. Again, the rule is that you want to do minimum damage when you get rid of somebody. Okay? The lowest priority ones should be gotten rid of. So, what Android does is it ranks all the processes that are part of the Android system at any moment into a 5-level hierarchy in increasing order of importance based upon what the components that are part of the process are doing. Okay? Obviously, and the highest priority would be a foreground process. What is a foreground process? A foreground process is a process that is hosting a component which is occupying the screen. What kind of component will be occupying the screen in Android? What are the 4 components in Android? What's the only component that can occupy the screen in Android? Activity. The reason why I keep reminding you over and over again is that it needs to become part of your vocabulary, okay, an activity. Okay, the process that is hosting that activity, because remember that every component needs to be running inside a process. Whenever the component is activated, the corresponding process needs to be created. So a foreground process is the one that is currently occupying the screen. That's the highest priority. Obviously, it makes absolutely no sense to get rid of it. Right? So next higher priority than that is what is called as a visible process. What is a visible process? A visible process is a process which might be hosting components that are not foreground components, but they can still affect what the user sees on the screen. For example, you have an activity from which you popped up a dialog box. So the activity is still visible in the background, but the dialog box is occupying the screen. So the process of the nature could be a visible process. The third kind is a service process. What is a service process? A process that is hosting a service, started with the start service. And a service process is not one that could be classified as one of these two. Okay? If it so happens that, I'll come to the point in a minute. The next one is what is called as a background process. What is a background process? A background process is a process that is hosting an activity that is not currently visible to the user. So this activity is in the background. The stack, task stack is in the background. So it's not occupying the screen. So it's a background process. And then finally, you have empty processes. Now, why does Android keep around processes like this, even empty processes? Because creation of a process takes a lot of time. If you want your system to be responsive, even if none of the components of an application are active, you will still keep the process hanging around. Because if the process is already there and created and the PCB and everything is initialized, it is a lot more easier to restart the process than to recreate a process all the way from the scratch. Okay? That's why you will keep empty processes hanging around. Now, if push comes to shove and you need to get rid of somebody, who do you think you would get rid of first in this hierarchy? You'd obviously start at the bottom, right? You'll try to get rid of empty processes first. If that satisfies your, if that results in releasing of enough resources, okay, no problem, you'll continue from there. Otherwise, you'll pick background processes and so on, until you reach a point where you'll kill a foreground process, which rarely will happen. Okay? So that's the importance hierarchy in terms of processes. Yeah.
Can you explain a little bit about the difference between the service process and background process? Because I think maybe service process are running on the background.
Yes, but a service process is more important than background process.
Huh?
A background process is not a service. You know there is a component called service in Android. Right? If you use a service component, it will be classified there. This is if you run any background thread. I will show you examples of how you can run background threads without using a service. Okay, you can do background work using background threads, but you won't be using a service, but instead you will be just doing work in the background. That's a background process. So, now what Android does is, of all the processes that are currently active in the system, Android will try to give them the highest importance that it can. What it means is that if a process hosts a service and also a visible activity, in principle you could classify this as a service process. But instead, since it is hosting a visible activity, the process will be classified as a visible process, not a service process. Because a visible process has higher priority than service process, higher importance than service process. So Android will always try to give every process the highest possible importance that it can assign to the process. So that way it will try to retain processes as much as possible. Furthermore, a process's ranking might be increased because other processes are dependent on it. Suppose I am a service process running in the background and I am doing service for you and you are a foreground process. Okay? You are a foreground process and you invoked my service and I am the service process running in the background, then Android will not try to kill me either. Because if it kills me, your job will be affected. You are a foreground process, you have a higher priority. So that's the thing. A process that is serving another process can never be ranked lower than the process that it is serving. So it will automatically acquire the importance of the process that it is serving. Okay? So that way, see, Android is not trying to get rid of processes. Android is trying to save processes as long as possible. But in the worst case, it tries to get rid of them. Processes running service ranked higher than processes running background activities. This answers your question. Okay. Background processes can be run as using background threads. But service processes will be ranked higher than background processes. So if you need to do a lot of work in the background, better use a service because Android will not try to kill the service processes as much as possible. Okay? So that's about the process lifecycle. What about threads? How many of you have written thread programs? Multi-threaded programs? Not even in the OS course? Nobody has experience with multi-threaded programs? Tough luck, my friends. Android forces you to write multi-threaded programs. But fortunately, Android provides you with nice framework which makes it easy for you to implement multi-threaded process. Okay? I'll explain step by step. Okay? Threads. In Android, the thread of execution is created whenever an application is launched. You remember I talked about the main thread in one of the earlier slides? This main thread is also referred to as UI thread, user interface thread. This is the primary thread that controls everything for the application. Okay? This is in charge of dispatching events to the appropriate UI widgets, including drawing events, the UI widgets. And this is the thread for the application to interact with the Android UI toolkit components. Everything that you need to do on the screen is controlled by the UI thread. Okay? Anything that you need to do on the screen, you need to take the help of the UI thread. The UI thread is the only one that can do anything on the screen. So if you need to do any updates on the screen, you have to ask the UI thread to do it. All components are instantiated in the UI thread of the specified process. So if you start up multiple components, all those components will be running on the same UI thread. Okay? UI thread is the thread of execution for the particular process. So system calls to the components are dispatched from the main thread. And methods that respond to these calls always run in the main thread of the process. So this is the main thread or the UI thread which is controlling everything. So if you try to do a lot of work on the main thread or the UI thread, you'll run into problems, as I will show you in a minute. Okay? If you perform long operations such as network downloads or database queries on the UI thread, this is a novice mistake that every beginning Android programmer makes. And I'll show you examples of how you can make that mistake. Okay? If you inadvertently start doing downloading and thing or doing long computations inside an activity or inside any one of the uh, listeners and so on in the activity, it might end up resulting in the UI being frozen from the application. Okay? What will result in something called the ANR, application not responding dialog. Now, if you do long computations on the UI thread, you will see this ANR dialog coming up on the screen, and it will freeze the screen, basically. And it will ask you to, it'll ask whether it should still continue to wait for the work to be finished or should it terminate the process. Okay, should it terminate the application. So this is bad. If a user starts up your application and then encounters an ANR every so often on your application, then pretty soon the user will get mad at you and then uninstall your application, and you have lost a customer. So always try and make sure that you don't do things like this. Anything that may not be completed quickly should be assigned to a different thread, to a worker thread. And I'll show you code where you can do that in practice. And fortunately in Android, you simply make use of Java thread facilities for doing this. The UI thread, the UI toolkit itself is not thread safe. What does thread safe mean? If you have heard the term reentrancy, you know what thread safe things are. Let me briefly remind you about it, and then I will, in the next chapter, I will actually explain reentrancy in more detail. Why did you need semaphores in your operating system's course?
To protect consistency.
Consistency of who?
The executing data.
When you're trying to change any variables and so on within your application from two different places simultaneously, to maintain consistency, you need to protect the changes there. Now, if the UI of Android application is being modified from several different points simultaneously, suppose you say, okay, I'm going to implement a multi-threaded application because I don't want to do everything in the single thread, and then you happily go about implementing multi-threaded application. From each one of those threads, you try to update the user interface. Unfortunately, the Android's UI is not protected. So if two different threads manipulate it, then it will result in a havoc. So what Android specifies is that if you need to modify anything on the user interface, you should always ask only the UI thread to do it for you. You should not be manipulating the user interface from anywhere else. This is Android specification. How do we comply with this specification? I'll explain with techniques for doing this in practice. So when you implement applications, there are two rules that you should remember. First, do not block the UI thread. So do not do long computations inside any activities, inside any of the handlers or event listeners. If you do that, you will end up freezing the screen. Second, do not access the Android UI toolkit from outside the UI thread. Let only the UI thread manipulate the screen. How do we comply with this second request? It's not that difficult because Android provides several